All right, we're starting a new chapter called probability, basically. A lot of the stuff you have learned last year, but we are adding to it. So this lesson is called theoretical and experimental probability. You can measure the chance of an event happening with probability. The theoretical probability is the chance that some event should happen, and that would be given by this ratio here. So the probability of something happening, so this just stands for probability, and then this will be what they want, that'll go inside the event, is the number of favorable outcomes, so what you want over the total possibility. Experimental probability is what actually happens when an experiment is repeated a number of times. So again, the probability is the number of favorable outcomes that actually happened to what could have happened. And then I'm going to switch highlighters here, but the odds in favor of an event is the ratio that compares the number of ways the event can occur to the number of ways that it cannot. I'm going to write a ratio over here on the side. The odds against an event occurring is the ratio that compares the number of ways the event cannot occur to the number of ways it can occur. So it's a ratio, so it's going to look like that. So I'm going to write it as a colon, but it's going to be compares can occur, so something that can, to cannot. That's the odds in favor. Odds against would be cannot occur to the events that can occur. So we'll practice that here in a second. This would be the new stuff from not last year. A bag contains 6 marbles, 1 blue marble, and 3 yellow, so there are 6, 7, 10 total marbles. 1 marble is selected at random. Find a theoretical probability of each outcome. So that's what should happen. The probability of getting a yellow, well, there are 3 yellows out of 10. So there's our fraction. The decimal form would be 0.3 and 30%. I might ask you for 2 of those. I might ask you for all 3. Just read the directions. Blue or yellow, so I'm happy if I get a blue or yellow. So blue plus yellow. So 1 plus 3 is 4 out of 10, which is 0.4 and 40%. Moving it 2 spots to the right. What are the odds in favor of picking a red marble? So in favor, so how many can we get? Red, red, red. That'd be 6. Against how many that cannot? So we cannot get 4 of them, 6 to 4. Against it, so cannot occur. There are 4 ways it cannot occur, 2 6 ways that it can occur. So those are like reciprocals of each other. This is the 6 red, and this is the blue and yellow. So it can occur to cannot. Cannot occur to can. 10 marbles are selected from a bag of colored marbles. The results are shown on the table below. Find the experimental probability of selecting a red marble. So this is what actually happened. So how many total did we do? 4, 6, 10 total. Out of getting a red, we got a red 4 out of 10 times, which is 0.4 and 40%. How many times should we have gotten it? So I'm just going to write that just so we can compare it. Experimentally, that's what happened. In theory, there are only 3 colors. And if there's an equal amount, then we should have, in theory, the same thing. So we don't know that for sure, but theoretically it would be like 1/3, 0.33, and 33%, because there are 3 different marbles, as long as there are an equal amount of each, but it doesn't tell us. But that would be experimental. This is the difference of theoretical. A couple practice problems. Bag contains 5 red, 5 blue, 6 green, 8 purple, and 1 white. So 5, 10, 16, 17, 25 total. 1 is selected at random. Find the theoretical probability of each outcome. Express each theoretical probability as a fraction and as a percent. So in theory, getting a white, there are 1 out of 25, which if you divided that or multiplied by 100 to get to 100, that's 4 out of 100. Or 400, so 0.04, which is 4%. White, blue, or green. 1 blue is 5, green is 6, so that would be 12 out of 25, which would be out of 100, that would be 48 out of 100, so 0.48 and 48%. You could just divide those in your calculator to get that, but I'm just using equivalent fractions. And red, blue, green, purple, or white. Red, blue, green, purple, or white. That's all of them. So we have a 100% chance, or a 25 out of 25% chance of that happening. Now these were just asking for the fraction and the percent. So make sure you simplify your fractions. On to the back, we have sometimes when you can make predictions when you know the probabilities. So it says use a sample to make a prediction. To make a prediction about an event that will happen in the future, take a sample or survey of all the outcomes. Then use the experimental probability to predict how often that event will occur. So this one says shoes. The chart at the right shows the number of people wearing different types of shoes in Mr. Thompson's English class. So we've got 10, 22, 28 students total in his English class. Suppose there are 300 in the cafeteria. Predict how many would be wearing low-top sneakers. Well, in Mr. Thompson's English class, 12 out of 28 are wearing them. So a couple ways to do this. You could set up a proportion, say 12 out of 28 equals x over 300. You could cross multiply and get 28x equals 3,600, and then divide by 28, which is 128.6, which would be 129 students. Or what we could do is we could use the percent of this. So 12 out of 28, this is another option, is, rounding to the nearest whole percent, 43%. So we take 43% of the 300 students. So I'm just going to keep this number in my calculator and take it times 300, and we get 128.6 again. So either way, we're going to end up with 128.6 or 129 students. You can just pick whichever one you like to work with, proportion or percent. So we have similar problems here. I probably won't do all of these. Just do the first. I'll just do 1, 5, and 3. Car, let's see. It says 100 drivers, 37 said they drove cars, 43 said they drove trucks, 12 vans, and 8 drove motorcycles. Well, car, and we want to figure out of 5,000. What's nice about this 100 is that this car is 12, no, not 12, 37 out of 100. I already know that that is 37%. So 37%, or 0.37, times the 5,000 that I'm working with, gives me 1,850 drivers. If I go to 3 van, that's 12. Motorcycle is 8, so that'd be 20 out of 100, or 0.2, or 20%. So if I just take 0.2, or 0.20, times 5,000, that's going to give me 1,000. Drivers. You know what, I'm actually going to skip, no, yeah, we'll skip that one and go down here. And we'll just do 8. Same type of thing, predicting. Insurance company insures this many homes. Of those homes, that many are in fire, this many are fire and flood, and the rest are for flood. So, out of this many, we're going to take a prediction. So we need to figure out flood only. Fire and flood. So if they give us all of it, we need to actually figure out how many have flood only. So that'd be 2342 minus 1,234 minus 456. That will give us our flood only. That's 652 out of 2,342, which is about 28%, 0.28 or 28%. If I then multiply that, I'm just going to keep it in my calculator, times the new total, or the new whole, it should give me, when we round, 3,446 homes. So we have talked about theoretical experimental probability, using the experimental probability to make predictions. That was over here. And on the front, remember that we talked about doing some odds in favor versus odds against. And use these ratios to help you on those. Have a great day.